After completion of my 2-year diploma in agriculture program, I entered the OUSL BIS agriculture program for the continuation of my further education. As a person who engaged in the field of education management and industry training in Sri Lanka, I serve my valuable knowledge for OUSL as a visiting academic and industrial expert on a regular basis. Highly experienced, well-behaved and well-qualified staff members at my OUSL life. I think it was a very good opportunity to the continuation of my education under the field of agriculture.
I was able to understand, experiment as well as gain the most of advantages of open distance learning model offered by the Open University. So with this model, I was able to learn myself, experiment things by myself and make that theories into practical as an engineer. So in that way, the academics in the Open University as well as the facilities like laboratories, library and all the other academic staff and non-academic staff was very helpful to make our journey a success.
Began the journey with Open University soon as I finished my A-levels. Industrial exposure we got from Open University is priceless. Knowledge I gained was able to make me who I am today. And the theoretical knowledge and the technical knowledge was very beneficial and influential. Today, I'm a successful woman in my field, in my career, thanks to the degree I obtained from Open University.
Good morning. I warmly welcome you to the International Open University Research Sessions IHours 2022.
IHours 2022 is an important annual event of the Open University of Sri Lanka. IHours established itself as a high caliber research forum that attracts not only researchers from the OUSL community but also other state universities and higher education institutes as well as overseas researchers, creating a forum for presenting and discussing valuable research findings leading to enriching experience to the researchers. IHours significantly contributed to enhance the research culture among the OUSL staff members in ODL, Open and Distance Learning, and disciplinary-based research areas, which directly inspired our staff members to participate at other international and national and international conferences by contributing holistic research findings. That IHours 2022 will bring you renewed motivation and enthusiasm to engage in more productive research.
IHours 2022 provides an opportunity for sharing knowledge created through research across various disciplines. I am particularly pleased with the choice of this year's theme, that is, Contemplations Towards Next Normal for a Smart Future, Directions and Dimensions. This is an approach emphasizes the requirement for educators and researchers to embark on creative thinking to formulate strategies to overcome unforeseen contingencies. Therefore, no doubt that this conference aims at breaking away from the traditional models of higher education and opening doors to new, innovative, creative and visionary conceptions. And this will also be a stepping stone for further development of Open University of Sri Lanka's national and international advocacy campaigns.
I'm delighted to introduce our chief guest, Professor Dr. Ebba Ossianilsson. Professor Dr. Ebba Ossianilsson from Sweden is an independent consultant, expert, influencer, and quality auditor in the field of open, flexible, online, and distance learning.
Thank you so much for the kind invitation to participate at your and contribute to your wonderful conference. It's a great pleasure and honor for me to be chief guest at your prominent conference with a timely theme on contemplation towards the next normal for a smart future, directions and dimensions.
The research sessions of the Open University of Sri Lanka is a very important annual event of the OUSL calendar that is indeed much looked forward by all tiers of the university. However, there is certainly a lot of groundwork that was involved in organizing the conference from inception to reality. Ladies and gentlemen, on behalf of the organizing committee, I'm honored to be here this morning to thank all those whose contributions have made today a reality.
The first keynote speech of IHours 2022, which will be delivered by Professor Arjuna Parakram.
I see my role today as trying to do precisely that. I want to talk to you about the serious issues that we face. I want to encourage you to contradict me, to argue with me, to fight with me, so that we can produce a kind of engagement that goes beyond the platitudes of our times. So I hope, I'm very privileged to be here, and I hope that you will not decide that you made the wrong choice after you hear me talk. My title is Resisting the Aftershock Dogma, Rejecting Neoliberal Economic Policy as the Engine of Change in Educational Principles and Practice.
Good morning, everyone. I think all of you can hear me. I would like to welcome all of you for the day 2 session, parallel session 1, session 4, parallel session 1, and we are going to start the session 4 of today. Today's session chaired by Dr. Iresha Attanayake. I would like to invite Dr. Iresha to start the proceedings. In the meantime, I will ask to all the participants who are wish to present today, please rename yourself with the paper ID. Then it's easier to identify you. Thank you. Dr. Iresha, it's up to you.
Thank you, Dr. Gunasthekar. I think we should start. Sorry about the delay in bit. We were supposed to start at 9:45. I would like to invite the first paper presenter, paper ID 111, a study to investigate the most suitable seam stitch combination for side seam of shirts in relation to seam strength and seam breathability by KPC Manesha and Emiya Pereira.
International Open University Research Session 2022. I am KPC Manesha. The research topic is a study to investigate the most suitable seam stitch combination for side seam of shirts in relation to seam strength and seam drapability. These are the contents of the presentation: introduction, objectives, methodology, research design, data collection and analysis, results and discussion, conclusion. Let me give a little introduction about the research. The apparel industry is a fast-growing competitive industry. Nowadays, many other alternative technologies such as molding, spot welding, adhesives, etc. can be used to construct garments or to join fabric panels. Although there are new technologies to construct garments or join fabric panels, still the most popular method is the sewing technique. Sewing is assembling the garment pieces together with the thread or threads formed into stitches producing a seam. When considering the construction of shirts, side seams can be constructed using various seam types, stitch types and stitch densities. Those sewing construction parameters should be selected carefully in order to obtain high-quality seam constructions. Though research studies have been carried out for seam properties and characteristics by using various materials and parameters, research studies have not been done to determine the suitable seam stitch combination for the side seam of shirts. The main objective of this investigation is to find out the most appropriate seam types, stitch types, and stitch densities for side seams of shirts in relation to seam strength and seam drapability, which influence both physical and performance features of seams. Methodology: a literature survey was carried out to gather information in relation to the topic. Appropriate fabric type, sewing thread type along with 2 ticket numbers, 3 seam types, 4 stitch types along with 3 stitch densities and 5 suitable seam stitch combinations were selected for the experiments. The testing standards, machines and equipment for seam strength and seam drapability testing were also selected. A total of 150 samples were prepared as per the testing standards. Out of these 150 samples, 75 samples were prepared for the testing of seam strength. For each seam stitch combination, 15 samples were prepared, 5 samples each for 3 stitch densities. The same procedure was followed to prepare the other 75 samples for testing of seam drapability. The samples were tested for seam strength and seam drapability to determine the most appropriate seam stitch combination for side seam of shirt. Research design is divided to three parts. Part A, selection of materials and construction parameters. Selected conditions for both tests are shown by the table. Fabric, fiber content 65% polyester and 35% cotton. Fabric structure plain weave. Weight 102 grams per square meter. Ends per inch 117. Picks per inch 79. Sewing thread 100% spun polyester. 75 ticket number for overlock stitches and other bottom stitches. 50 ticket number for other top stitches. Stitch densities 12, 14, 16 stitches per inch. Seam type superimposed seam type A, lap seam type B and C. Stitch type single needle lock stitch 301, double lock chain stitch 401, 3-thread overlock stitch 504 and 5-thread overlock stitch 516. Selected seam stitch combination. There are 5 combinations. SSA with 504 and 301, SSA with 504 and 401, SSA with 516, LSB with 401, LSC with 401 with twin needles. Part B, selection of standard machine and equipment. For seam strength test, testing standard ASTM D1683, machine tensile tester, Tinius Olsen tester. For seam drapability test, testing standard ISO 9073-9, machine and equipment, drape meter and electronic balance. Part C, preparation of the samples for testing. For seam strength, 5 samples each for 5 seam stitch combination, 5 samples each for 3 stitch densities, so the total sample 75. It is the same for seam drapability test. Data collection and analysis. For reference purposes, fabric strength and fabric drapability of 5 unsewn fabric samples were measured. The average fabric strength value and fabric drapability of unsewn samples were 469 Newton and 1.1853 respectively. The individual seam strength and seam drapability values were measured by using the prepared 75 samples for each experiment. By using these values, average values for each specimen set and for each stitch density for both seam strength and seam drapability were determined. Results and discussion. This figure shows the average value of seam strength of 5 specimen sets, which includes 3 selected stitch densities for the study. It shows that the seam strength has been increased in set 1 to 4 with the increase of the stitch density. In set 5, with the increase of the stitch density, the seam strength has been reduced. The set 5 shows the higher seam strength, whereas the set 2 shows the lower seam strength. The higher seam strength was shown by the samples of 12 SPI in the set 5. The lower seam strength was shown by the samples of 12 SPI in the set 2. The seam strength analysis can be performed to many other different combinations. This figure shows the average value of seam drapability of 5 specimen sets, which include 3 selected stitch densities for the study. It shows that seam drapability has been reduced in set 1 to 5 with the increase of the stitch density. The set 2 shows the higher seam drapability, whereas the set 5 shows the lower seam drapability. The higher seam drapability was shown by the samples of 12 SPI in the set 2. The lower seam drapability was shown by the samples of 16 SPI in the set 5. The seam drapability analysis can be performed to many other different combinations. The last part is conclusion. As a result of this investigation, it was clearly found that the seam strength and seam drapeability depend on the selected seam stitch combination and stitch densities. It was also found that the fabric strength of unsewn sample was higher except in all the set samples in set 5 and 16 SPI samples in set 4. In the case of seam drapeability, it was found that fabric drapeability of the unsewn samples was higher than the samples in all 5 sets. That means the introduction of seam reduced the drapeability. The highest seam strength was shown by the samples of set 5, which is the seam stitch combination with LSC and 401 with twin needle. The lowest seam strength was shown by the samples of set 2, which is the seam stitch combination with SSA and 504 with 401. In case of seam drapeability, the highest seam drapeability was shown by the samples of set 2, which is the seam stitch combination with SSA and 504 with 401. The lowest seam drapeability was shown by the samples of set 5, which is the seam stitch combination with LSC and 401 with twin needle. Further studies should be carried out to improve the findings of this study with increased number of material types, stitch densities, thread types, etc. The presentation is over. Thank you.
Thank you very much, Ms. Vanesha. Let us see whether there are any questions. The floor is open for questions. I would like to invite participants to ask questions from the presenter, if you have any.
I would like to ask one question. Now, what is the normal seam stitch combination presently used in the shirts in the industry? What's the practice? Can you have any idea about that?
There are many stitches used widely. Lap seam and superimposed seam are used widely, as well as single needle lock stitch and double lock chain stitch used with that these seam types.
Yeah, have you considered that also in this research, that particular type also?
Yeah.
Okay, now as per the results, what you can comment on the normal industrial practice and your results?
I can suggest LSC with 12 SPI for seam to achieve higher seam strength. It is the better way to achieve higher seam strength.
Okay, but presently it is not commonly used, isn't it?
Because it gives because it is not used well widely due to the cost.
Okay, yes, I can understand. Yeah. I think it's good research based. Thank you.
Thank you, Vanesha. Yeah, I have one question. So this is particularly for the shirts, right? Is there a specific reason why you have chosen shirts?
Yes, madam. We can use this for woven materials, not only for shirts. We can use this experiment for this investigation for blouse, which produce using woven materials, as well as inseam and out seams of trousers, as well as frocks, side seam of frocks, which manufactured using woven materials.
Okay, so what made you initially do this for the shirts?
Because shirts are widely used, produced garment. This is not a fashion garment. Shirts are not going out of fashion. So we always we can shirts are widely used garment. That's the reason.
Okay, okay. Okay, thank you very much. And thank you very much for your wonderful presentation. Let's move to the second presentation. Second presentation, paper ID 112, a study to investigate the possibility of using washed blood stains in selected cotton and polyester woven fabric as direct forensic evidence by HRN Sumanasiri and Emir Pereira. Over to you.
Welcome everyone, my name is HBN Sumansiri and this is a study to investigate the possibility of using washed bloodstains in selected cotton and polyester woven fabrics as direct forensic evidence, which was supervised by Dr. Emir Pereira. This is the content plan for this presentation. First, I'm going to do a brief introduction for this project, and then I'm going to state my objectives and methodology regarding this research, and then the research design, data collection and analysis, results and discussion, and finally the conclusion. First, the introduction. Forensic science could be defined as the application of scientific principles and techniques to solve matters of criminal justice, especially relating to the collection, examination, and analysis of physical evidence. When considering modern-day forensic investigations, the knowledge of textile science could be mainly utilized for bloodstain pattern analysis. When compared with other types of evidence, bloodstain pattern analysis could produce a more definitive conclusion. A study has been carried out on cotton t-shirts to enhance the bloodstains on washed clothing. As per the literature review, it was found that no specific research studies have been carried out on bloodstain analysis on cotton and polyester woven fabrics, which are widely used as household and apparel textiles. The objective of this study is to investigate the possibility of using washed bloodstains in selected cotton and polyester woven fabrics as direct forensic evidence to provide justice against criminal activities. When considering the methodology, the first step was to conduct a comprehensive literature survey in relation to the research study. Then the experimentation stage was conducted on 4 sets of fabric samples amounting up to 60. They were used to produce strip and spatter stain samples, and the results were photographed. Those 60 samples were then washed in 3 cycles by using a domestic detergents after allowing 24 hours for stain fixation as per the part C, which is said to be at rest of designing the experiment. After each washing cycle, the results were photographed. Thereafter, dried samples after each washing cycle were treated with luminol and the results were photographed. By using Adobe Photoshop software, original bloodstain samples were compared with the respective luminol-treated bloodstain samples after each washing cycle. Then finally, the relationship between the original bloodstain and the luminol-treated bloodstain samples were analyzed by using the ImageJ software. Then the research design for this research. The research design could be divided into 4 separate stages. Part A is the preparation of samples. This table represents the summary of preparation of samples. As you can see, we have divided the number of samples into 4 types in order to produce strip and spatter stains. Part B focused on simulation experimentation. These simulation experiments were carried out to produce strip and spatter bloodstain types on each set of samples. These 2 images represent drip tower apparatus and modified mousetrap apparatus, which were used to create drip stains and spatter stains respectively. Then the part C, which was for washing and drying stage. In here, sample washing was conducted as per the ISO 6330 of 2012 standard using the Innova DFA N60 top-loading agitator type washing machine, which is a domestic type washing machine. 3 washing cycles, each of 12 minutes, were conducted by withdrawing 5 samples from each set, totaling up to 20 samples after each washing cycle, and introducing fresh 5 samples from each set to the washing machine in order to keep the weight constant. Finally, the line drying stage was done for 24 hours by keeping the warp direction vertical. Final part D was focused on testing the stain samples with luminol. In here, the luminol powder was used to produce a 250 ml of solution. 3 pumps of those solution were then applied to each sample in order to surface the already washed stain. This application of samples was done inside a dark room in order to obtain quality photographs. Meanwhile, the photography was performed immediately after the application of luminol to each sample. Then the data collection and analysis. This table represents the summary of data collection. In here, a separate code was given for each type of sample. For example, DC represented drip stained cotton samples, while as DP represented drip stained polyester samples. In addition to this, a number was given for each fabric sample in order to recognize its washing cycle. For instance, samples underwent only 1 washing cycles were labeled 1 to 5, and the samples labeled 6 to 10 attended 2 washing cycles, and samples labeled 11 to 15 underwent all 3 washing cycles. These 4 images represent the respective stages of the DP1 sample, which underwent only 1 washing cycle. The A image represents the sample just after stain formation, and the B image represents after 20 minutes of stain formation, while D represents the stage after washing and drying, and D represents the luminol stain. Results and discussion. When considering the results of this research, they can be divided into 2 based on qualitative and quantitative nature. This table represents a summary of analysis of qualitative data. As per the results, it can be concluded that 55 out of 60 samples tested were matched with the testing definitions of polyester and cotton bloodstains. Therefore, this qualitative analysis can be used with 91% accuracy in order to identify whether the luminol tested samples had a drip stain or a spatter stain. Out of those 5 deviated samples, 4 samples were cotton. The reason could be the natural fiber structure of the cotton samples. This table represents a summary of analysis of quantitative data. When considering quantitative data analysis, a statistical t-test was conducted for average stain length as well as for stain area of each of the sample types. Although this table represents only the average stain length for polyester and cotton drip stain formation. Only the drip stain cotton samples tested after 3rd washing cycle showed a significant difference in the tested parameter of average stain length based on this table. The reason could be the combination of the natural nature of fiber composition and the increased number of washing cycles. When considering the conclusion for this research, as per the results of the qualitative analysis, the washed bloodstain type can be identified with over 91% of accuracy irrespective of fabric type. As per the results in relation to the average stain length, it can be observed that there is no significant difference between original bloodstains and the washed bloodstains in polyester samples after respective washing cycles. It was also observed that there is a significant difference between original bloodstains and the washed bloodstains in cotton samples after the 2nd washing cycle. The reason could be the combined effect of fiber type and the number of washing cycles. This project was conducted as a preliminary study to investigate the possibility of using washed and dried bloodstained fabrics as direct forensic evidence in criminal justice. But further studies should be carried out to validate this outcome we researched by using an increased number of samples on the selected fabric types. That will be the end of this presentation. Thank you very much.
Thank you. Thank you very much for your presentation. Now it's time for questions. Any questions from the audience? Just unmute your mic and speak up if you have any questions to be posed to the speaker. All right. I would like to ask you, Miss Sumanasiri, right? Yeah. So why 3 washing cycles, not 4, not 2, not 5? Is it a standard?
That is not a standard, but I wanted to conduct an average preliminary research because when considering the past crimes and the confessions of the past convictions, it was realized that a lot of the criminals had washed to an average of 3 cycles. So that's why I choose 3 cycles.
Okay, so now most of the cases reported, they were trying to wash their clothes for 3 times. Yeah?
Yes,
Is
exactly.
that the reason?
Yes.
So in average.
Yes.
Okay, so now I would like to know in that case how they have identified that it's through the confession, right?
Yes.
How they have identified that they were trying to wash them for 3 times.
No, there is no scientific method to identify how many cycles they have been, but it's through the confessions.
Okay. Okay, and the other thing is why this particular 2 types of fabric? Once again, this is for my curiosity actually. So why this is cotton and polyester?
Because when we are considering the normal scenario in any domestic or even in automobile incidents where many crimes has occurred, either they are mainly we mostly wear cotton fabrics, and those fabrics, even technical types of fabrics, are made of mostly even from cotton and polyester, and even with their blends. So if this preliminary research was conducted for 100% cotton and 100% polyester, then in the future we can establish the connection between like 60% cotton and 40% polyester, and such all such blends of those types of fibers. So like I said, this is a preliminary research, and that's why I choose these 2 mainly used fiber types, considering the statistics, past statistics.
Okay, okay, thank you very much. And one last question. And you said the match was 91%, right? So that is purely based on the resolution, because you're comparing the 2 images, right?
The 2 images, according to the definitions given by the Security Council of USA, it's based on yes, the images.
Yeah.
Yes, it's
So
a visual
this is
comparison.
purely visual comparison. Oh, resolution comparison.
No, there were
so
2 analyses.
If it is a visual, if it is a visual comparison, how do you come with a number 91%?
Like I compared the individual stain with the definition. So in that case, there were 55 out of 60 samples matched with the definition. That's why we could establish it was 91%.
Okay. Thank you very much. Any other questions from anyone? Anyone, any other questions? Right, if not, let's move on to the third presentation. Thank you very much, Ms. Sumanasiri. Next is paper ID 120, determining factors leading to successful utilization of biomass for power generation in Sri Lanka by N.C. Tantirigoda and J.G.A.S. Jayasekara.
Very good morning, dear ladies and gentlemen. The topic of my presentation is determining factors to successful utilization of biomass for power generation in Sri Lanka. The study was carried out by Mr. N.C. Tantirigoda and by Dr. Sari Jayasekara. If we go to the background of the study, there has been an increasing interest for renewable energy since the beginning of the last 2 decades, and mini hydro, wind, rooftop solar are some of them. However, the contribution for this from biomass is significantly low, and this study aims at finding factors leading to successful utilization of biomass for power generation in Sri Lanka. If we go to research gap, in the research carried out so far is limited to the study of potential of growing biomass in Sri Lanka and to few technical aspects. Only a single research paper has been carried out on a failed plant, and none of these studies have comprehensively addressed the reasons why biomass power plants were not successful in Sri Lanka. Therefore, there is an obvious research gap related to the factors favoring development of biomass energy generation in Sri Lanka. And if we see the methodology carried out in this study, the methodology adopted involved in collection of relevant information from various sources, analyzing them, and finally making suitable recommendations. A summary of the methodology utilized has been given below. The first one is that we carried out a literature survey of the relevant case studies, environmental reports, policies, and legislations, including court cases. And secondly, we conducted interviews with the experts from the biomass industry of Sri Lanka. And thirdly, we analyzed the information collected in the research literature survey to ascertain the reasons for lack of success in biomass power generation in Sri Lanka. And lastly, we made some recommendations for improving biomass energy generation in Sri Lanka. Here are the key findings from the literature survey. First of all, we would like to go for the national energy policy. The policy focuses more on the usage of biomass for household cooking purposes and industrial thermal applications, and it fails to include explicitly biomass for electrical power generation, which may have a negative impact on its future development, discouraging investors and causing reluctance among banks to provide funds as opposed to hydro, mini hydro, solar and wind projects. And the policy does not appreciate the important advantages of biomass power generation associated with growing resource material in the form of trees, which contribute towards the environmental cleaning and also earning carbon credits. Here I have listed the key findings from the legislation aspects. On the left hand side, as you can see from the slide, in the old legislations, the non-renewable power plants had to go through this competitive bidding process, and after completing the bidding process, the plant is being established. And for renewable power plants, it didn't want to go through the competitive bidding process. So what they have to do is they had to take up energy permit from the Sri Lanka Sustainable Energy Authority, and then the biomass power producer can develop a sustainable or a viable supply chain for biomass, and then the power plant can be established. In this case, the biomass power producer has sufficient time to establish a viable supply chain. However, in the legislation introduced in 2013, all the power plants had to go through this competitive bidding process, and then for the renewable plant,
they had to take a permit from the Sri Lanka Sustainable Energy Authority, and then the plant can be established. In this process, the biomass power producers does not have sufficient time to establish a viable supply chain. And here I have listed the key findings from the interviews. First of all, if we see the biomass industry, according to them, the main reason for the failure of biomass power plants are the usage of outdated technology, errors in plant commissioning, lack of local expertise, management issues such as failure to purchase spare parts in advance, undue delays in obtaining approvals, which may lead to frustrating developers. And if we consider the banking sector, the lack of proper maintenance plans, use of inferior parts of machinery, and difficulty in having a proper supply chain have contributed to the failure of most biomass power plants. So this may lead them to or the banks to be reluctant in providing loans for developers. And from CEB side, the CEB acknowledges the salient features of biomass power generation such as community benefits and advantages related to road controlling for them. However, the CEB finds difficult to pay for higher charges to the developers. Here I have illustrated a case study of a failed biomass power plant which was operated in Tirappane long time ago. So this power plant is a 3 megawatt gasifier based power plant, and here are the problems which were associated with this gasifier power plant. The first one is that there were environmental problems, which the problems related to disposal of tar of the gasifier, and technical aspects. If we consider, it was essential to maintain the correct moisture level of the firewood. If not, excessive tar would be formed in the gasifier, clogging the gas lines and damaging the engine. And it was difficult in maintaining the correct air-fuel mixture of the engine, and also the gas cooling unit also consumed a large amount of energy, which ended up having a large amount to pay for energy bills. And there were also administrative problems of not having the correct amount of spare parts. So considering all these problems, this power plant failed, and this further shows that the gasifier technology is not suitable for large scale power plants. Here I have finally I have listed the conclusions and recommendations. The first one is to recognize the biomass electricity generation on the same footing as other renewables such as wind, solar, mini hydro, rooftop solar, and also value the special advantages of biomass energy generation due to its capability of securing carbon credit and other advantages which cannot be expressed and quantified in economic terms in the national energy policy of Sri Lanka, encouraging the developers to pursue biomass electricity generation, and also give special consideration for biomass electricity plant developers, taking into account the difficulties confronted by them due to necessity of developing on purchasing the source material as opposed to other renewable sources which are available free of cost, and the time taken for establishing a reliable supply chain, and also expedite the energy permit granting process for the developers. Further, for the conclusion, for the recommendations, the biomass power producers should also be given assistance and advice on carbon trading scheme, and they should be provide the technical support for proper installation of machines, designing machines, and operate and maintenance, and also considering the social benefits such as provision of employment on large scale. The bank should make special types of banking loans for the power plant producers. So that's the end of my presentation. Thank you very much.
Thank you very much, Mr. Tantriguda. Now it's time for questions. Anyone wants to pose any questions, please. Hello.
Hello, is something good? Can you hear me?
Yes, sir, I can hear
Yeah.
you.
Yeah. My question is now, have you done any cost comparison relevant to the biomass product electricity produced out of biomass and the other sources? Any cost comparison?
No, sir. My research was based on a quantitative research, quantitative, factors. So I have done structured interviews, going through case studies, and other legal cases or legal aspects also. But generally, considering the power, in terms of the cost, the power generation is from biomass is much higher than other renewables.
But if it compares with the normal fuel, through the fuel, maybe it's cost effective, isn't it?
It comes to the
within your research, you have not focused to that area. The cost comparison has not been done, no?
Yes, sir. Yes, not done.
Okay, now the second question is now, what is the main challenge to implement this biomass thing in Sri Lanka? Have you identified any challenge in the practical scenarios?
Yes, sir. The first one is that now the energy policy does not, the energy policy, first of the things that the national energy policy does not recognize biomass as a power generation source. So if they consider it as a power generation source, then the other investors would be investing in this power generation production. So
Okay,
that's the main
other than that, in technical side, do you have any difficulties to find the equipments and all these things? So what's your opinion there?
Yes, sir. From the study I carried out, I found that there are no expertise in there are few expertise in installation of this machinery. So that's the main issue from the technical aspect.
Yeah, Mr. Nipun, one small question from me.
Yes,
can you hear
sir.
me?
Yes, I can hear you.
Yeah. Can you use municipal waste for this project?
Municipal waste.
You have to separate them anyway, but
you have
at
to
least
separate.
part of
First
that.
thing is that you will separate them.
Yeah.
You can't. The first thing is you can't use polythene and others, polythene and things like plastic. But you can use. Yes, you can use.
Yeah. In that case, when you calculate the cost, I think you have to think about the waste elimination cost also. That is an added advantage for the country. If you can.
Yes.
Yeah.
Yes.
Okay.
But the only problem is the thing, people in the CEB, they don't consider this as they only look at the cost of the fact, they look only at the figures, the numbers of the unit cost, but they don't consider that aspect.
Yeah, but that is very important aspect, no?
Yes.
Otherwise, you have to spend additional money for the waste elimination. Right?
Yes, sir. Yes.
As I understood, the power plant in Kerawalapitiya, I think they use this municipal waste, right?
Yes, sir. Yes.
Yeah.
And also, even for this biomass power generation, there are a lot of community benefits also. People get jobs, and farmers and all those things, they gave additional income. So none of them are considered by these policymakers.
Sure. Okay. Thank you for the answer. Right.
Anyone? Any questions? Any more questions? All right. Mr. Santrigoda, I have one question. Now, in your presentation, you said that for gas cooling, for the particular power fund that you have considered here for this study, gas cooling, there are lots of energy needed and therefore the cost will be high, right? Gas cooling. Now, at the stage of designing the power plant, haven't they considered that one anyway? They are trying to use this renewable energy, right? So haven't they considered that fact at the design stage?
From the discussion, madam, it seems like they have not correctly identified that issue. Yes, that's correct. They have not considered that issue very well. So that also because of low expertise, knowledge of them in designing these plants.
Okay. Okay. Any more questions? Anyone? Okay, if there are no any other questions, let's move on to the next presentation. Next present paper ID 128, respiratory system related several diseases detection system using lung sound analysis by MHMN Hera, GNGLCA Karuna Tilaka. Over to you.
Good morning, everyone. I am Chamat Aditya. Our project topic is respiratory system related several diseases detection system using lung sound analysis. First, introduction. Respiratory diseases are among the most common causes of severe illnesses and death worldwide. The number of people affected by COPD is 65 million and asthma is 339 million. Asthma is a disease affecting the airways characterized by variable and reversible airflow obstruction. It causes recurring periods of wheezing, chest tightness, shortness of breath, and cough. COPD is a disease state characterized by airflow limitation that is not fully reversible. The airflow limitation is usually progressive and associated with an abnormal inflammatory response of the lung to noxious particles or gases. Aim of this project is analyze the acoustic parameters from respiratory signals in COPD and asthma patients and develop a system with enhanced accuracy. Objectives are develop a classification model using lung sound analysis and develop an electronics device to classify COPD and asthma patients. Methodology includes 9 functional blocks as shown in here. Lung sound audio taken from patient first going through amplification process and then feed into Raspberry Pi using USB sound card. Then Raspberry Pi records 22-second audio clip and low pass filter to 3000 Hz. After that, extracted MFCC features sent to the server, which is in this case my laptop. Inference part done in here using train model and then result sent to the client. Finally, the result will display on OLED display. First part is audio input method. Lung sounds are normally low-pitched sounds. Therefore, it is not possible to collect audio using normal mic. So we designed a device using condenser microphone, stethoscope chest piece and preamplifier which will sensitive to lung sound. Using that device, patient's lung sound detected and preamplified, which includes NE5534 low noise op-amp. Then amplified audio sent to Raspberry Pi through USB sound card for analog to digital conversion. This audio recorded and low pass filtered to 3000 Hz, then sent to feature extraction process. Here used mel frequency septal coefficient feature extraction process for audio feature extraction. By using extracted features, inference part was done in a laptop. Here laptop act as the server and Raspberry Pi act as client. In Raspberry Pi, MFCC feature convert into 2D array and sent to the server with a request of inference result. In the server side, it will receive MFCC data and predict lung condition with train model. Finally, result will send to Raspberry Pi and result will display on OLED display. Connection between Raspberry Pi and laptop established by using mobile hotspot and Flask web application framework. In model training, there are total number of 1526 data and to reduce data imbalance, created additional 741 data by performing data augmentation methods. After extracting MFCC features from that dataset, model training was done by using convolutional neural network. MFCC feature extraction process contained with 6 steps as shown in diagram. First step is separate the sound signal block into frames. Then each frame is sent through a Hamming window to remove high frequencies in edges and keep the continuation of sound signal when combining each frame again. After that, each time domain frame is connected into the frequency domain by fast Fourier transform. And then Mel scale applied to this result. Finally, the coefficients are calculated by taking the log of Mel power spectrum and then calculating discrete cosine transform. CNN contained with three convolution layers, with ReLU activation and max pooling, two dense layers, which are first one is flattened output layer and second one is softmax output layer. In this process, convolution operation extract the feature maps of MFCC image and ReLU activation brings the nonlinearity. Max pooling process reduces the dimension and computation power. Flattening converts a 2D feature array into a single array to fully connected classification. Finally, softmax activated dense layer to find the probability value for each class. Below shows the CNN architecture parameters from 2267 data. 10% allocated for testing and 10% allocated for validation. Model training successfully finished with 92.8% test accuracy and random data testing accuracy as follows. In this study, a detection system of COPD, asthma and healthy subjects in a real time with classification of lung sounds using CNN is presented. For this purpose, at first MFCC features were extracted, then these features were used for classification. The model training result shows that the MFCC feature extraction method with CNN has better accuracy. Electret mic with stethoscope diaphragm was a better low-cost method for sensitive lung sound recording. But electronic stethoscope will do a better job, also it will be expensive. My suggestions for future work includes using a large amount of balanced data for model training, but using cloud platform servers for inference. The detection process can be brought into mobile devices with wireless stethoscope, so it will be convenient for anyone in the medical field. Thank you everyone.
Thank you, Mr. Karunatilaka. Now it's the time for questions. Any questions, please? Right. I just want to ask you now in CNN, you have used this ReLU for nonlinearity, right? Yes. So what is the significance of having nonlinearity here?
Because madam, this is audio data sets are not, we cannot classify using linearity method as CNN likewise. So we have to, it's a process of processing CNN. That's it.
No, yeah, I'm just asking because you're trying to get purely audios, right?
Yes, ma'am.
And then you're using purely audios to train CNN, right?
Not purely audios.
Yeah,
Feature extraction using MFCC method. MFCC feature blocks are sent to the CNN method.
Yeah, but your input is audio, right?
Yes, right.
Okay, okay. So input is audio. Yeah, that's what I want to know. Okay. Any other questions from anyone? And you said you use 10% for training and 10% for validation, right?
Yes,
Is
madam.
that so? Is that so?
Yes, madam. Hello.
Yeah. Can you hear us?
Hello.
Yeah. Can you hear us?
Yes, madam. Yes.
Okay. Okay. So if there are no any other questions, let's move on to the next presentation.
Sorry, Resha, I do have a question.
Yes. Go ahead,
Uh,
please. Yes.
Yeah, no, he was telling 10% for validation,
Yeah.
and 10% for training. What is with the other part, the remaining data set?
87.
With the
80%.
misinterpretation.
That's why I specifically asked you. I was just wondering why. I don't know.
Maybe a mistake, I think. All right, okay, we'll go to the next.
Next presentation. The next paper ID is 134. Investigation on the suitability of paper pulp in the production of lightweight, non-load bearing cement blocks by H.I. Ahmed, L.N. Ahmed, T. Sianesan, LSS, Vichevardhan. Over to you.
Hello, good morning everyone. I am Ijaz Ahmed, representing paper ID 134. Our title of research is Investigation on the Suitability of Paper Pulp for the Production of Lightweight Non-Load Bearing Cement Blocks. First, let's see a small introduction of this research. Cement blocks are widely used currently in the construction of walls. The main ingredients used in the production of conventional cement blocks are ordinary Portland cement and fine aggregate, which is M-sand here. If these cement blocks can be made lighter while maintaining the required engineering properties, it would reduce the dead load applied to the structure, resulting in a reduction in the size of the structural component, which is cost effective. Moreover, lightweight cement blocks make handling and transport much easier. And now let's have a look at the objective of this research. This research study was conducted to explore the feasibility of producing lightweight cement block by partially replacing fine aggregate with paper pulp obtained from waste paper, which is abundant and cheap. An additional advantage of using paper pulp is its outstanding heat insulation and soundproofing properties. Moreover, the use of paper pulp in cement block manufacture reduces the amount of paper that end up in landfills and making it sustainable techniques. Sri Lanka Standard Institution has published standard applicable to the requirement and test method for cement blocks. This research study explores the effect of using different percentage of paper pulp in cement blocks to achieve the optimal mix proportion in cement blocks. Now let's see the methodology. Manufacturers of typical cement block use cement sand ratio up to 1:40, and there is a doubt about satisfying the compressive strength requirement specified in SLS 855. Due to the expected reduction in the compressive strength when paper pulp is added, a few preliminary studies were carried out to determine the optimum cement sand ratio, the water cement ratio, and the appropriate paper pulp replacement range. Based on the outcome of these studies, it was concluded that the paper pulp replacement should be done within the range of 28% and 34% of fine aggregate, with an optimum cement sand ratio of 1:8 and water cement ratio of 0.7. The table here shows the composition of the material used in study. The paper pulp percentage indicated in the table is the percentage of M-sand replaced by paper pulp. The blocks 305 mm, 152 mm into 102 mm in size were cast in a block yard that manufactures cement blocks for commercial purposes. This is the time for results and discussion. First, let's see compressive strength test. The blocks were tested for compressive strength according to SLS 855 Part 2, 1989. Individual blocks were cured for 3 and 7 days. Before being taken for testing, the compressive strength was tested with a compressive strength testing machine. According to SLS 855 Part 1 of 1989, the minimum strength of non-load bearing cement block should be 1.2 Newton per millimeter square. However, it does not specify an exact curing period. When we have a look at the figure, this figure shows the compressive strength test results of samples obtained after 3 and 7 days. Now it is time for water absorption. This test was carried out conforming to the SLS 855 Part 2 of 1989 as shown in the figure. The peak value of water absorption of 227.6 kg per meter cube was observed for 34% of paper pulp replacement percentage. It also lies below the SLS 855 Part 1 recommended maximum acceptable limit of 240 kg per meter cube. Next test is moisture content test. It was carried out conforming to the SLS 855 Part 2 of 1989. The upper limit recommended is SLS 855 Part 1 for moisture content of cement block is 40%. Variation of moisture content with paper pulp percentage is shown in this figure. According to the figure, it can be said that all the values lie below the 40% upper limit. Finally, the test for block density. Wet and dry densities of cement blocks were tested by obtaining wet and dry masses of cement blocks selected from each set of blocks cast from each mix. The test was conducted according to SLS 855 Part 2 of 1989. Here, the figure shows the graphical representation of the wet density and dry density test results. The results of blocks density values fall in between the maximum value of 2800 kg per meter cube and the minimum value of 1000 kg per meter cube respectively as recommended in SLS 855 Part 1 of 1989. At last, this presentation is concluded with conclusion and recommendation. The primary aim of this research was to produce a lightweight cement block satisfying all the requirements specified in SLS 855/1989, applicable to cement blocks, partially replacing fine aggregate utilizing paper pulp obtained from waste paper. Results of the compressive strength, moisture content, water absorption and block density test recommended in SLS 855 for cement block indicated that cement blocks made with 30% replacement of fine aggregate with paper pulp have achieved this after 7 days of curing. 30% replacement can be considered as the optimum percentage replacement since any further increase in the amount of paper pulp fails to achieve the required compressive strength of blocks 1.2 Newton per millimeter square that is recommended for non-load bearing balls. SLS 855/1989 does not specify any curing period to achieve the specified compressive strength. It only says that this strength need to achieve the day blocks are taken out of the casting yard. Since the compressive strength results of cement blocks tested after 3 days of curing fail to achieve this, it is a requirement to cure cement blocks for 7 days in the casting yard. It also gives around a 14% reduction in a dry density and a 10% reduction in wet density when compared to the control block. This reduction in sulfate leads to substantial saving in the construction cost of structural elements. Further, even without any test results from this study, it can be concluded that savings are possible in energy cost due to the expected heat insulation property of added paper pulp. The durability aspect of these blocks could not be studied since there is no such test recommended in SLS 855 due to the fact that conventional blocks are made with cement and aggregates and have no durability issue. However, it is advisable to conduct a suitable test to study in the durability. Thank you.
Well, thank you very much. Now it's time for questions.
I have one question. Now, you said that now this is a lightweight block. Now, how about the weight reduction? I think the presentation we have not seen any slides relevant to that. Have you checked that?
Yes, sir, we checked it. That's the main purpose of conducting density test. According to our calculations, we were able to get around 14% of weight reduction when comparing to the 14% of reduction.
40% reduction. Now, my second question is, why did you select this 28 to 34? Is it from previous literature or something like that?
So actually, we did some preliminary studies to find the exact range. It means for the replacement range. From those preliminary studies only, we got to know that 28 to 34% would be better to find a most appropriate solution.
You more focus to that area for the further studies, ne?
Yes, sir.
Okay.
Right, any other questions?
One more question. I don't know whether this is relevant to the research work. So, what is the benefit of weight reduction in cement block?
Dr. Eric, that was not very clear, your voice. We lost you halfway through. Could you please, could you please repeat the question, Dr. Eric?
Low weight, right? Now, properly. Yeah, can you hear me?
Now it's okay. Now it's okay. Thank you. Yeah, go ahead.
I do not know whether my question is 100% relevant. But as I understood this, using the paper pile will result in the lower weight in the cement block, right? So, what is the advantage of producing cement blocks with lower weight?
Sir?
I think that question is basically what we asked, Dr. Eric asked was now what is the reason for using lightweight material?
No issue.
Dr. Eric, I hope that is what you are asking.
You can continue.
Yeah, by reducing the weight of
yes, I think you can answer. I hope.
Shall I proceed?
Yeah, you proceed.
By reducing the weight of a single unit of block, we can also by using same kind of blocks, we can reduce much weight in the structural weight altogether. By reducing much structural weight, we can also reduce just the cost for by reducing the size of structural component. Like we can reduce the beam size, column size, like that. So by doing so, we can cut down a good amount of money from our budget. So that's why we are going for lightweight blocks for non-load bearing purposes.
Okay, Dr. Eric, can you hear us? I think he answered. I don't know whether that was the expected answer for what you have asked. Dr. Eric, can you hear us? I think, yeah, any more questions?
So then the next question is, when you
Yes.
produce lightweight, yes, okay, I'm happy with that. Yes.
Right. Any other questions? Any other questions? Right. I just want to ask you now, what is the compromisation for the compressive strength?
According to SLS, the minimum compressive strength that a non-load bearing block should have to have is 1.2 megapascal. I mean 1.2 Newton per millimeter squared. That's what the minimum value non-load bearing block has to have.
Okay, so what is the compressive strength of this particular blocks?
According to our research, the 30% replacement has reached that value, that mark, 1.2 Newton per millimeter squared mark. Other than, yes, that's also the optimum value.
Okay. Okay, thank you very
That you were able to achieve the requirement with the replacement of 30%, no?
Yes, sir.
Okay, any other questions? You can have, we can still accommodate a couple of questions since this is the last presentation. Anyone?
One more question, Dr. Iresha.
Yeah, we can hear you clearly now. Yeah, we can hear you clearly. Yes.
So when the cement blocks are lightweight, so how it affects the stability of the construction?
So I didn't get you clearly.
No, what he's asking is when they are lightweight, the blocks, how it affects the stability of the structure.
Actually, the main reason for going for lightweight block is to reduce the self-weight of the complete structure. So we are using these kind of blocks not everywhere. It means we are using just for the non-load bearing purposes only. The places where non-load bearing walls has to be constructed are the places where we are going to use these kinds of blocks. It means they have to resist only their self-weight. They don't bear any loads from the structure. So there won't be much issues related to that stability.
Okay, thank you very much. I understood, right? Answer is clear.
Okay, thank you. I think with that, we finish today's session. I would like to thank all the presenters today and thank you very much for answering the questions. Actually, we improved our knowledge on areas that we never thought of. Having this type of things existing. Thank you very much once again. And also, thank you very much for all the participants for actively participating to the sessions. And with that, we will finish. Have a pleasant day, the rest of the day. Thank you.